So if we are going to test our distribution of favorite colors of M&Ms, then we're going to need a null and alternative hypothesis. So we'll consider a multinomial experiment of k outcomes. For us, it's the M&M experiment for a single quantitative variable, which is the number of counts. Results are going to be displayed in what's called a one-way table. So before we get to that, let's go ahead and record our preferences here, null and alternative. So let's test if Olivet students' favorite color of M&Ms follows the candy maker's distribution. So same data as above. We're testing blue 24%, orange 20%, etc. So let's say that we did the results of a color preference survey. So we surveyed our 30 Olivet students and asked them what their favorite color of M&Ms were. Let's suppose that we have the following results. Of those 30 people, 8 said that blue was their favorite color, 3 for orange, 7 for green, 5 for yellow, 6 for red, and 1 for brown. So those are what are called our observed values. And then what we expect in the null hypothesis, what we're testing against, and we're going to assume is true unless it's proven otherwise, is the manufacturer distribution, which is 24% blue. So that's the first proportion, 0.24. And then 20% orange, so 0.20 for P sub 2, 16% green, so 0.16 for P3, and then 14, 13, and 13 for yellow, red, and brown, 0.14, 0.13, 0.13, and these do all add up to 100%. And then remember, the alternative hypothesis is saying that the null is not true. So what has to happen for this null hypothesis to be not true? That means the observed values here in the table don't follow these proportions. So that doesn't mean that they have to differ on every proportion. So some of the proportions could be the same, but they do have to differ on at least one proportion. So we would say at least one proportion differs from the null. So at least one proportion doesn't follow the manufacturer's distribution. So that's the setup, null and alternative hypothesis for the test that we want to conduct.